turn on a singer, you turn on voice, your YouTube content creator. Going back to the gas stoichiometry problem. Problem number 4. 7.45 grams of solid magnesium carbonate is heated until it completely decomposes into carbon dioxide and magnesium oxide. What volume of carbon dioxide gas will be produced at STP, at standard temperature pressure? Okay, it's very clear in this problem, guys, that there's a chemical reaction. We're going to heat the magnesium carbonate. Okay, heat like this. And then completely decompose into carbon dioxide and magnesium oxide. So, for example, if the combustion products, it's still under combustion products, right? But in organic, okay? Like that, because combustion is not limited only to it's not limited only to organic compound. The process combustion is applicable also to inorganic. But the only difference, guys, the other compound may not be the same. May not contain carbon and hydrogen all the time, but still this is combustion because there's heat involved and it decomposes into carbon dioxide. Even though there's no water. Okay? It's a point. Something like that. When you heat, of course, there's oxygen is in there, normally in the atmosphere. Okay? Like that. Okay. Decomposition is one type of chemical reaction. Okay. We need to put the chemical reaction first before going further. Okay? So, magnesium carbonate. How can we have the chemical formula? Because it's not mentioned here the chemical formula. It's only word, magnesium carbonate. So we have also to be smart enough to determine the chemical formula. Something like that. Now, carbonate, guys, is a polyatomic ion that has a charge of -2. Okay? So it just happened here, magnesium has a charge of +2. If you take a look in the periodic table, this is belong to group 2A. So 2A meaning +2 charge. See, +2. I'll just explain for a while so that we can understand clearly. Because it's not given, the chemical formula. In case there's a chemical formula given, you don't have to worry. Okay, something like, so -2. So crisscross theory, the charge of carbonate will be here in the magnesium side, and the charge, and it will become positive. Of course, it will transpose there. And the 2 magnesium will be going there to the carbonate, like that. Okay? Now, it will become also negative, something like that, right? Okay? Because it was transposed. So, cancel. -2 and +2. So, it will become, because unlike charges will be cancelled to become neutral compound. Okay, as magnesium carbonate. That's the rule. Neutral compound, it should be have 0. So we need to say 2 minus 2 is equals to 0. Like that. Now, since it is already a neutral compound, you have to erase this subscript and it will now become magnesium carbonate. Ganon. Okay, like that. Okay? So just like calcium carbonate, okay, limestone, have the same, sharing the same chemical properties because they are in the group 2 and the same charge also. But in here, magnesium carbonate, okay, like that. So magnesium carbonate is heated. The sign in chemistry will be arrow going to the right, and there's a triangle, a small triangle that would represent the symbol of heat, and we will call that as delta, okay. So heat, like that. Okay, understood. If there's heat, there's an oxygen, rapid oxidation within the heat. Okay, like that. And then it will produce magnesium oxide and CO2. You will take into consideration that CO2 will always appear. Okay, like that. Since there's no hydrogen in this original reactant, it is not expected water will come. Get the point? Though it is also behaving a combustion chemical reaction at some point. Okay? Though this is a decomposition reaction specifically, but sometimes at some point this will be combustion. Okay? By definition, something like that. Okay, it will become magnesium oxide, okay, plus CO2. Okay, now you should put first the CO2, okay, so that the remaining will be adjusted. What do you mean by will be adjusted? Meaning to say, okay, you estimate the oxygen, the magnesium, the carbon like that. Okay? Because in this case, guys, if there is a carbonate, by theory and principle, it will yield carbon dioxide immediately. Okay? Then what will remain? There's still one oxygen remain. So this one oxygen, since oxygen is very reactive, it will react to magnesium. Reactive gas, meaning to say it needs stability by reacting to other elements. The most reactive element is oxygen in the planet Earth. To the point, that's most reactive. So due to his reactivity, so automatically without question, this will become flammable in its characteristic, this oxygen. That's why we have oxygen gas cylinders as flammable due to its behavior as reactive. So meaning to say, if the elements are reactive, it is also flammable in nature because it goes together by principle and in theory that it is directly proportional with each other. The more it is reactive, the more it has a high flammability. Something like that. So in this case, oxygen will react to magnesium. So it will become magnesium oxide. But as I teach you, put first the carbon dioxide and then the other one will be adjusted. Okay, so take note. If you split the carbon dioxide here, remain oxygen. So it will become magnesium oxide, right? Now, put charges now just to prove. Though this magnesium oxide is already a neutral compound, because we don't put charge anymore, okay? Again, if we don't put charge anymore at the top of the compounded element, that is neutral. Meaning neutron is equal to zero. Okay? Meaning positive charge plus negative charge is equals to zero. Meaning to say, it will not become an element or a compound if that is not neutral. You get the point? It will become charged if it will react to element are in a chaos solution. Without any reaction, will remain neutral in nature. You get the point? Though the instructors and professors will not tell you that it is neutral, but it is understood to be neutral. Okay? No need to explain further. Okay? Something like that. Okay? So, we need to balance the chemical reaction. Magnesium balance, oxygen 3 plus 1, 3, and carbon 1. Perfectly balanced without adjusting the number of moles. By visual inspection only. Okay, now, the basis of calculation is 7.45 grams of solid magnesium carbonate. Canon. Okay? So we cannot use here standard formula and equation again. Okay, let's make this clear. If we are dealing with stoichiometry calculations, for example, solid, gas, liquid stoichiometry calculations and problems, you don't have unnecessary formulas and equations all the time. You always use the basis of calculation of what are represented or presented in a problem. You get the point? In this case, guys, there is only one given. Okay, 7.45 grams. Okay, because if we will use a standard formula and equations, at least minimum of 2 data. But this only one. So the first thing that comes in your brain cells, oh, why is this only one? How can I solve this? So that could mean you can use the dimensional analysis conversion way of problem solving. Now, solution proper. Solution. Like this, okay? So 7.45 grams of solid magnesium carbonate. Ganon. Okay. Now, there's a gram and multiply with a gram in the denominator of magnesium carbonate so that it will cancel with T. So how can you do that? By considering the molar mass always. Molar mass. Okay? like that. So, molar mass of magnesium carbonate based on my memorization, that is, ala, 84 point something. Sige lang, let's say 84.39. Okay? Not to be exact, the important thing is we know how to solve it, right? Okay, 84.39 grams mol. And this is all about magnesium carbonate, the numerator and the denominator. Okay, what you found out, grams will be cancelled immediately. Okay, most of magnesium carbonate. Number two is to look at the balanced chemical reaction. This is the second step talaga siya in dimensional analysis. Look for the balanced number of moles in the chemical reaction all the time, guys, if calculations. Okay, number two is siya na step. Okay, in here, under the denominator, most of magnesium carbonate. Take a look in the chemical reaction. We have only one molecule of magnesium oxide here, and we have also one molecule of magnesium carbonate. So you will say 1 mole or molecule of magnesium carbonate will just be equal to 1 mole of magnesium oxide. Then cancel the mole of magnesium carbonate. What will be left is 1 mole of magnesium oxide. Now, go back to your problem since it has been asked volume. Okay, and then there's an STP. So automatic in every ideal gas, it will occupy 22.414 liter of a gas. Like that. So meaning to say here, it is the CO2 gas that will behave ideally. Okay, not the magnesium oxide, not the magnesium carbonate, because they are not gases in nature. You get the point? They are not gases in nature. So take note, it will also ask what is the volume of magnesium oxide magnesium carbonate. Do not use the 22.414 liter. Because magnesium carbonate and magnesium oxide will precipitate as a solid residue. It will never vaporize to the atmosphere. Only the carbon dioxide will vaporize into the atmosphere. So it's exclusively the CO2 will act as an ideal gas, no other in this particular chemical reaction. Okay. Now, going back to our solution proper. Now, in every 1 mole of blah blah blah, okay, ganon. Okay, so how many kaya magnesium oxide ba ito di pangita? So, magnesium oxide sa inyong butang diri. Now, if CO2 mo di pangita, CO2 po di mo butang diri. So, since volume of CO2, then we need to focus for CO2. Okay, 1 mole of CO2, and then 1 mole of CO2. Okay, 1 mole of CO2, 22.414 liters. Okay. So, by common sense, you will not use the magnesium oxide and magnesium carbonate because it is not a gas. Remember, okay? Like that. And then, if the problem will say, what is the volume of magnesium carbonate and magnesium oxide will be produced at STP? So, meaning to say, your question is already wrong. Okay? So, meaning to say, the choices, there will be none of the above. Something like that, because you cannot solve that because magnesium carbonate and magnesium oxide will not behave ideally, only the CO2. So things like that should be captured in our brain cells, okay? And it's only a trick. Sometimes they will ask the magnesium carbonate here, what volume of magnesium carbonate will be produced at STP? O ganon, right? And it is not applied as for 1 liter because it's a gas. Things like this. Now, if you will try to force the grams, something like that, okay? Force the grams, okay, but you can use your stoichiometry relationship, and then most of, let's say, magnesium oxide, still you attain a gram, not the liter. So you will use the density now, okay? Density, you get the point? Density or the molar mass formula. For example, only I'm just, playing my wild imagination. Okay, for example, if gibitik ka mo, for example lang ha, kaysa yun naman kainin natin kung takuman. Okay, for example, if what volume of magnesium carbonate and magnesium oxide will be produced at STP? So, literally wrong. If the choice is there in the examination, so you should put none of the above. If there's no none of the above, then you have to force yourself to find another formula to match this question. Okay, even though it was phrased incorrectly. That's the technique. Because some questions are hypothetical. Doesn't have to be in reality. Hypothetical meaning measuring only how you understand the context of the topic. Something like that. There's no relevance in actual. No, getting only how you understand it. Something like that. Okay, let's assume. Okay, like that. So for example, so we change this to 1 mole of magnesium carbonate, okay, and then you will consider the molecular weight of magnesium carbonate, di ba? Ng 8.59. So, kasalan mo na naka-mole, okay. Pila ka mole, example lang, X mole of magnesium carbonate, ganun-ganun chuba-chucho, okay. Now, molar mass, di ba? Molar mass is equal to the ganun-ganon, molar mass is equals to molecular weight, ganon, and then the moles divided, okay, the mass divided by the moles, ganon, molecular weight, grams per mole man siya, right? Grams per mole. So mass divided by the mole, mass divided by the mole, okay, ganon, chupa-chucho. Now, nakay molecular weight, nakay moles, makuha niyo ang mass. Okay? Pagkuha niyo sa mass, guys, okay, naman kay formula sa volume in terms of mass na aba, okay, density is equals to mass over volume. Ganon. So you can solve for the volume because na kay mass, ang density mong problema. Now, asa naman sa hindi mo kuha ng density? Okay? Asa naman sa hindi mo kuha ng density? Ato na siya sa table. Right? Ato na siya sa table. It is given, supposedly, if pugsun yun sa question to ask what volume of magnesium carbonate will be produced at STP. So it could have been na siya density, half density, or what, no density, but you have to refer that to the table using the 0 degrees Celsius because you have T is equal to 0 degrees Celsius. Density of magnesium carbonate at 0 degrees Celsius and 1 atmosphere. You have to get that in the table in the book just to force to have the volume because you have now the mass you computed in the chemical reaction. You got the point? That is only the case if there are choices in a question. But if there is none of the above, choose none of the above because magnesium carbonate and magnesium oxide is not really a gas. Okay, then why we will use the principle of STP and using letter per mole, 22.45 per siya. So it's gonna be tricky sometimes, but you have to be extra careful to the phrasing of the sentence. You know, phrasing, how it is being restructured, something like that, so that we can understand really. So English is an advantage in interpreting the question. Okay, something like that. Okay, going back to the solution proper, calculator please, ganon. So dira atong pa na, kuha na tag liters ani nilang sa carbon dioxide, something like that. Okay? Okay? Na kung imo yung isog-isuro nimong self, pwede mo makuha ang density through using PV and RT. Something like that because STP magud siya. STP, it's also okay to use the PV and RT. Okay, and there's a pressure, 1 atmosphere, and you have the number of moles na nasa reaction sa magnesium carbonate, magnesium oxide, right? And universal gas constant, ang constant niya, okay, in terms of mole. Dito po, since liter atmosphere siya, because liter man ang ipangita sa, sa problem. And then, temperature, 273.15, then bingo, you can solve for the density, because you can correlate density in the PV and RT. Okay, that's the point. You can correlate that there by using mass over V, density, and play around the manipulation of the quantity. You can get density there. Okay, the same as concentration. Then substitute it here also. Okay, like that. Okay, but I think this is more closer rather than going to the standard table. But actually, it will match. Because when you go to the table in the book, you're not using the PV and RT, you're using the same operating conditions, which are 0 degrees Celsius and 1 atmosphere. So basically, it's closer, right? To give you the density of either magnesium oxide or magnesium carbonate to get its volume. equals to density is mass over volume, or directly go to the 15RT para di mo nakamutan ako sa table. You get the point? There are two ways or approach. That is only the case if we are asking for magnesium carbonate and magnesium oxide volume at STP in this case. Okay? Ganun siya. Really, you have to think all the time in this kind of approach. Okay? It's not all the time that when you solve it directly, it is already correct. Sometimes you have to think, it is logical, it is valid, it is reliable. Oh, why like this? Very small. Like that. Okay? Get the point. Now, calculator please. Moving on. So, I have here, like this, 7.45 times 22.414 mga kapatid is equals to divided by 84.39. Ganon. So, 1.98 liters of CO2. Again, 1.98. So, where is this one? 1.98 liters of CO2. Ganon. 1.98 liters of CO2. Now guys, in this case also guys, if all are 1 mole, ganon, chupa-chucho, 1 mole ba? Press ano? 1 mole of magnesium carbonate, 1 mole of magnesium oxide, 1 mole of CO2. So meaning to say, the number of moles will not matter that much. Okay? Because all are 1. Things like this also you have to consider. Unless there's a changes of the number of moles. You can also directly apply the PV and RT. In this case, PV and RT. Okay? And then you can compute the volume of CO2. Volume of CO2 is equal to the pressure over nRT. So, why I use this? Because the number of moles is only 1. For both CO2, magnesium oxide, but if this is not 1, then I siya pugsa. Use the dimensional analysis way of conversion. It just happened, puro siya 1. 1 mole of CO2, 1 mole. So it's equality. It's very clear and obvious in your chemical reaction. Okay. If you have a 1 mole of magnesium carbonate, when you hit that one, it will produce 1 mole of magnesium oxide and 1 mole of carbonate. So there's equality. Then if you use the PV and RT, then use that 1. For CO2, 1. Universal gas constant. Use the 0.08205 liter atmosphere. Mole Kelvin. Ganon, chupa-chucho. And then 273.15. Cancel ang mole unit. Nakay pressure. So pressure is 80 man. Di ba atmosphere na yun? Bingo, nakay volume. You get the point? Ganon. Okay? So, thank you so much for listening this problem number 4. Then, so, gano'n na siya, chupa-chucho. I take note, napala siya 7.4 grams. No, ipasok po to siya. Sorry, I forgot. There's a 7.45 grams dito, di ba? Sa question. Kung sa matong 7.4 grams. Dili mo may pasok, sorry. Kay magnesium carbonate man itong 7.45. Ating pangita CO2. Sakto. You get the point? Ganon. Okay, akang 7.45 grams ako man to magnesium carbonate man to okay, di man siya sa CO2 guys. Ano na siya pugsa. Okay? But if you want also, try to, manipulate things, problems, and then it can be completed na talaga siya. Maybe, okay, if you have 7.45 grams of magnesium carbonate, gano'n, it will also yield 7.45 grams of CO2. Why? Because in chemical reaction, there is 1 mole of magnesium carbonate and there's also 1 mole of CO2, directly proportionality. Then you need to also have to validate that. What's the reaction? What's the relation of mass and mole? Be sure that the mass and number of moles will be directly. If this will not be directly, then you cannot immediately see equal talaga siya mole. Let's say, mass siya, mole siya, mass. Mass, mole. So, molar mass ang doon. So, formula of molar mass. Okay? Molar mass, ganon. Mass over the number of moles. O ganon. So, the molar mass, okay? So, we can say, number of moles, molar mass, is equals to the mass. Okay na po siya guys. Because the number of moles is directly proportional to the mass. So we can say 7.45 grams of magnesium carbonate is also equal to 7.45 grams of CO2. Why? Because they contains both 1 mole in the chemical reaction. If it does not contain 1 mole each, then it will not hold through. It will not be applied. Okay? Because both are 1 mole. Okay? So meaning to say, pwede nyo ma-ratio and proportion because they are equal in property. Get the point mga palangga? Okay, like that. Okay, muna siya may tabo. Ano siya pagsabot isa? 7.45 is equal to 1. Ano? How many grams of CO2x? Ganon, di ba? Mga kalukat. And then, also 1. Oh, crisscross. 7.45 times x. Mura niya po. 7.45 good siya. Grams ang CO2. If in a chemical reaction, both are having 1 mole. If not 1 mole, ayaw pugsa. Okay? Ganon. Because it is in the relationship issue. If this happens also to be inversely, nah. It just happened that the mass and the number of moles are directly proportional with each other. Meaning to say, if the mass will increase, the number of moles also will increase, so dependent with each other. But if it is not, during the manipulation here, do not equate the grams of CO2 and magnesium carbonate is equal, even though it is 1 mole. You get the point? So that's the analysis behind for that. So din sa tanang panahon, hindi mo siya equal. Okay? Even though, pareho siya, 1 mole siya kanan, because the directly proportionality will not be the same. It's just happen na talaga, nakaiming na siya na ang number of moles o ang mass will go together. If number of moles will increase, the number also of mass will increase. So if it happens not even though we have 1 mole in the chemical reaction, you cannot say that this magnesium carbonate grams will be equal to the carbon dioxide. Not all the time, ba? So that's why you don't have to memorize, okay, how it is being done. Because if you will memorize, it will change. It will be modified, the problem, and you will be lost. Something like, because you always dependent. For example, I have kind of problem like this, and you will just pattern in this way. So problem, because maybe it will be modified a little bit, and you will be tricked. T-R-I-C-T, to rick. Okay, tricky, something like that. Okay, you get the point. And then most of the questions also in the examination will be tricky. Okay, it needs critical thinking. Okay, something like that. You get the point? Anybody you want to share, comment, and like, then you can do it. And if you're not subscribing my YouTube channel, you can subscribe. And of course, I will be happy if you try to click the notification bell for some newest updates of I Am a Singer, Italian Voice. Bye bye, God bless everybody. So we will be having our vlog number 5 later. Okay, thank you so much. Bye bye, God bless everybody. See you later. Kakaloka. Huy? Diba?